Hi, I'm Stuart Spray of Aerial Photoco Limited, and in part 2 of this presentation we'll be looking at how APCO-IMAGIS is used both as an interface to a GIS and as a data management tool. This is the main APCO-IMAGIS screen, and for the purposes of this demonstration, the system has been populated with 23 images organized in groups by altitude, 20 meters, 50 meters and 100 meters. These 3 filtering options will become more obvious later, but before we proceed, you can see here for each image we have the time and date of its origin, the GPS coordinates lat and long here, the altitude of the platform at the time the image was taken, the compass bearing, the direction that the camera was pointing, and its eventual image name as recorded. At the moment, these 2 columns, which will become of more significance later on, are blank. So the first thing I'll do is simply click on the first one and explain what you're seeing. First and most obvious thing is that the actual image itself has popped up in this preview window down here. Now this is a 6,000 pixel wide image, so not a lot of detail is showing here, but more of that later. Having clicked on the image up here, then the system has computed some basic information about the ground dimensions encompassed by the image, its width, this is in meters by the way, its width, height, the area that it contains, and at the bottom here the ground sampling distance in centimeters, the effective pixel size on the ground. In each corner we have the coordinates lat and long as computed by the system, and these eventually will get passed on to the GIS when we export the data files. Unless it's obvious at this scale that the image is not a suitable candidate, we'll probably have to look at it in more detail, in which case clicking the zoom button will bring up another window and allow us to have a closer look and decide whether or not it's a suitable candidate for inclusion, and if so, we can move on and perform the next step, which is first of all to mark this image as having been reviewed. This ensures that the process doesn't have to be repeated for the next time. When you come back to the system or somebody else comes back to it, they'll know that the image has been looked at. Okay, so whether the image is included or not in the GIS is another decision, and that's the purpose of the of interest column and the purpose of this mark unmark of interest button. And no surprises, if you click it, then the image shows as being of interest, in which case it will get included in the dataset exported to the GIS. If we want to filter down this dataset to only show those images that will be included, then we have an option up here, the of interest filter option, in which case we'll see just one image, which is the one that we've just processed. The process of reviewing and marking of interest will then simply repeat for as long as it takes to create your required dataset for export. And for the purpose of this demonstration, I've chosen 5 images for which I'm going to create an export dataset, and they are 6.7, 6.8, 6.9, 7.1 and 7.5. So now you can see there are 5 images which have been both reviewed and marked of interest. Those that are of interest will be included in the export dataset, and to make it a bit clearer, we can in fact filter these down on the screen here by selecting the of interest filter, and as you can see there are 5 images listed, 5 records, and therefore we now have our dataset ready for export. And the export process is simply a matter of clicking the export button, and as a result a confirmation message is shown indicating that 5 records were successfully exported to a chosen location. And if we look at that location here by opening the export folder, we'll see hopefully that we have 3 files, 79B, C and N, which we've just created, or the system has just created automatically. The B, C and N suffixes refer to, in sequence, the boundary box which I mentioned earlier, the coordinates of the image corners, and the nadir points of the images. So there are 3 files, and they are now available for importing into your GIS. We're now back in QGIS for the final step in this process, and we now need to import the files created by APCO-IMAGIS, and we do that in QGIS by adding a layer or layers, and in this case it's a delimited text layer because we exported CSV files from APCO-IMAGIS. If we browse for the files, we find the 3 files that we mentioned earlier on, and the first one that we'll import is the bounding box 79B. Next step is to choose the fields which represent longitude and latitude. Select a coordinate system, and the layer is created, not entirely visible because it's partially hidden by some of the existing layers, so we're just going to move it up the pile. So now we have the 4 coordinates of the bounding box. So that you don't go to sleep during the rest of this importation process, I'm just going to speed things up a little. So here we are with the 2 layers imported, the bounding box and the 5 images. And again, you may recall from part 1 of the presentation that we can in fact drill through these images and pull up some other data. And just to repeat what we did before, we can download an image that we have on a web server, could be on a local drive or on a network drive, and another one, 571. So we've now imported the bounding box, which is shown in grey here, and the 5 images in mauve. In this presentation, you've seen how APCO-IMAGIS can simplify the connection between aerial imagery and a GIS, how it can reduce the workload that's involved, and how it can create and maintain shareable records. We think that the effective management of data is as important and valuable as the data itself. So the facility to do this should be an essential feature of what we do. I hope you found this presentation interesting, and thank you for watching.